Hey everyone, so this is a follow-up to Notes M-1. This is the lesson we'll be doing in class the day after video M-1. So I've made this video for anybody that for whatever reason was not able to attend class the day after video M-1. So let's get started. You should have these notes that look just like this, except yours is yellow. Okay, if you don't have one, then I can get you one, but yours should be yellow. Okay, we'll refer to them for the rest of the year as your yellow notes or unit circle notes. Okay, and you will even actually use these going on into next year in calculus. Okay, so let's go ahead and get started. So let me explain what each of these things mean as well as what your expectations are. The dotted line here, D for dotted, is where you will put your degree angle measures. So D and D, that should hopefully make sense. The straight or the solid lines, excuse me, is where we will put the radian angle measures. Okay, and of course the dots is where we will put the ordered pairs. All right, so what the expectation is you will be given, and I won't say when, but here soon in the near future, you will be given this exact sheet of paper, pretty much. Okay, it might be a different color, but this exact sheet of paper, and you will be asked to fill out all of these pieces of information on the dashed line, on the solid line, as well as all the ordered pairs throughout the whole circle in less than 5 minutes. Okay, you are expected to memorize the unit circle. Like I said, we will be using it from here on out. For the rest of the year, we will be using this. And you need to be able to recall these from memory very quickly. So like I said, you will be given a quiz over being able to produce this same thing that I'm about to produce with you in less than 5 minutes. I will say I've never had anybody fail, and I will allow you to do it as many times as you need to get a 100. So just be aware that it has to be done in 5 minutes. If you need to come to tutorials to practice again, then so be it, but everybody should and will make 100 on this, just like they have in all years past. Okay, so let's get started. So again, the dashed is for degree, so let's go around the circle with degrees because I think that's the easiest first. So of course, you don't want to forget your degree signs. Let me actually use a color. Okay, so of course, this is our 0 degrees here, right? So we're at 0 degrees. Remember up here, we're at 90 degrees. Of course, here we're at 180 degrees. You already probably know all these. You're at 270 degrees. And then, of course, back that full revolution is 360 degrees. So you know I went around just adding 90 each time, right? Okay, and you also split that up, and you knew that half of that was this angle right here. Half of from 0 to 90, half was 45. Okay, so that was 45. And then I'm going to show you an easier way to do this. And right here, remember this angle right here. So if we take this 90 and if we split it into 3 equal pieces, which is what these two angles are. Remember, we talked about this before. If you split this 90 into 3 equal pieces, that'd be 30, 60, 90. So this is your 30, this is your 60, and this is 90. So now I want to talk about how you could quickly go around the full circle and know what each of these angle measures is. So notice that these are the same distance apart from each other as, like, you can basically mirror over the first quadrant to the second, to the third, to the fourth, etc. So to get from this angle to this angle, we're going up 30. But then to get from this to the next, we go up 15. Okay, to get from this one to the next, we go up another 15. So from 0 to 30 here, and then add 15 to 30, you get 45. Add 15 to 45, and you get 60. And then from here to here, of course, you can tell that that's a bigger angle measure. You add 30 again. So you could go around the full circle and know that your pattern is add 30, 15, 15, 30. And then start all over. Add 30, 15, 15, 30. So let's practice that. So 30, add 15, that's 45. Add 15, that's 60. Add 30, that's 90. So again, your pattern is 30, 15, 15, 30. So then, of course, you're 30. So if you add 30 to 90, excuse me, if you add 30 to 90, that's 120. So this is 120 degrees. Don't ever forget your degree symbols because then it's wrong. And then remember, it's 30, 15, 15, 90, 30, excuse me. So 30, add 15, so that's 135. Oh, you already knew that. You already knew that this was 135. We've talked about that previous to now. Okay, add 15 again. That's, of course, that'd be 140, 150, right? So 150, and then of course add 30, because remember it's 30, 15, 15, 30. Add 30, you get 180. Hey, isn't that what we anticipated? Yes. Okay, and then again, your pattern is 30, 15, 15, 30. So add 30 to 180, that's going to be 210. Add 15 to that, that's 225. Oh, that makes sense. You already knew that angle. You already knew that one. And then add 15 again, that's 235, that's 240. Okay, and then add 30. That makes sense because 30 plus 240 would get us at 270, and that's what we anticipated. And then start the pattern again. 30, 15, 15, 30. So add 30, that puts us at 300. Add 15, that puts us at 315. Add 15, that puts us at 330. And hey, add 30, that puts us back at 360, which is what we anticipated. And again, we already knew this was 315. So y'all, you can quickly go around the full circle labeling all the degrees by just following that pattern. 30, 15, 15, 30. 30, 15, 15, 30. So hopefully you should be able to produce that part very quickly whenever you do your quiz. Okay, so now let's talk about radians. So I guess I'll go ahead and use red and blue. So of course this is 0 radians, okay? And you already knew that this was pi radians. So let's just go around that way first. So this is 0, pi, 2 pi, and this is actually how I go around my circle whenever I do the quiz. Don't worry, I don't ever expect you to do something that I don't do. While you do your 5-minute quiz, I also produce the same thing in 5 minutes just to show you that I'm not asking you to do something that I don't already do. And yes, this isn't my first year teaching pre-cal, but I did it my first year teaching pre-cal too, and it was fine. I promise you will be fine. Okay, so again, 0, pi, 2 pi. So you already knew that half of pi was pi over 2. You already were familiar with this one, pi over 2. Okay, so we go around the circle with the radians in a different manner. I'll show you how. Okay, so for this, now I start to think about my pieces that are pi over 2 pieces. So from here to here, that's pi over 2. So I'm going to go the same distance, and I'm adding pi over 2 every time to get to the next. So I'm going to use a pencil just to show you. So to get from here to here, if I take pi over 2 and I add pi over 2, what does that give me? That gives me 2 pi over 2. Isn't this 2 pi over 2? Yes, it is. It's 2 pi over 2, which is pi, okay? But then add, to get the same, go the same distance, add pi over 2. What's 2 pi over 2 plus pi over 2? Oh, it's 3 pi over 2, right? If I add pi over 2 to that, it's going to be 3 pi over 2. Go the same distance. That puts me at 4 pi over 2. Oh, hey, what do you know? Is that 4 pi over 2? It sure is. It's 2 pi. Okay, so now let's take these pieces and let's split them in half. Okay, if I take pi over 2 and split it in half, that would put me right here at the 45-degree angle. That'd be my pi over 4. So let's go around the circle. And what I'm going to first do is I'm going to mark my pi over 4 pieces. So that's a pi over 4. If I'm cutting this whole pi into 4 equal pieces, that would be here, 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 and here. That would produce 1 equal piece, 2 equal piece, 3 equal piece, 4 equal piece, right? But let's do the same thing here. So let's show where my equal pieces would be and then come back here, right? Okay, so for pi over 4, we're right here. If you add pi over 4, we're going to add pi over 4 each time to get to the next piece. Make sure you have them marked. Okay, so if I add pi over 4 to get to the next piece, what's pi over 4 plus pi over 4? Oh, it's 2 pi over 4, which is equivalent to pi half, right? So then to get to the next, we add pi over 4. What's 2 pi over 4 plus pi over 4? Okay, it's 3 pi over 4, agreed? And then to get to the next equal piece, that would be 4 pi over 4. Oh, wait, is this equivalent to 4 pi over 4? It sure is. Okay, so then to the next piece, add pi over 4. So 4 pi over 4 plus pi over 4 would be 5 pi over 4. And then to get to the next, that would be 6 pi over 4. Hey, wait, is this equivalent to 6 pi over 4? It sure is. And then to get to the next, 7 pi over 4. Okay, and then to get to the next, 8 pi over 4. Is that equivalent to 8 pi over 4? It sure is. Okay, so now that we split up into the pi over 4, I think maybe next it would be best to split it into the thirds. Okay, let's do thirds next. So if I take this full pi, remember half the circle is the full pi. And if I split this up into 3 equal pieces, that's going to be here, here, and then of course here is my end. Okay, so that's 1 equal piece, 2 equal piece, 3 equal piece. So of course, this is going to be pi over 3 because we're in 3 equal pieces. So if this is pi over 3, then this would be 2 pi over 3. Don't you agree? Then this would be 3 pi over 3. Oh, wait, 3 pi over 3 is equivalent to pi. That makes perfect sense. Now let's take this half of the circle, which is a full pi, and let's split it up into the over 3's, right? 3 equal pieces. So that'd be 1 equal piece, 2 equal piece, 3 equal piece. Well, if this is already 3 pi over 3, then to get to the next third, okay, that would be 4 pi over 3. Then to get to the next third, that would be 5 pi over 3. Then to get to the next third, oh wait, that would be 6 pi over 3. Hold on, that simplifies to 2 pi. Doesn't it make perfect sense? Okay, so now that we've got our over 3 pieces, now let's split it up even further into our over 6 pieces. So if I take this full pi and I split it up into 6 equal pieces, that's going to be here, 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 and of course that ends me right there. Okay, so now notice what you're skipping. You're skipping the 45-degree marks or the pi over 4 because we want 6 equal pieces. So that's 1 equal, 2, 3, 4, 5, 6. So notice where my purple markings are. So this, of course, since it's 1/6 of the whole pi, this would be pi over 6. Okay, that'd be pi over 6. So if I go to my next over 6, that's going to be, since that's pi over 6, that's going to be 2 pi over 6. Oh, wait. Yes, it is. Then this is going to be 3 pi over 6. Simplify, and yes, it is. Then this is going to be 4 pi over 6. Oh, yep, it sure is. And the next purple mark, this is going to be 5 pi over 6. Yes, yes, it is. And then this is, of course, going to be 6 pi over 6. Oh, wait, it sure is. And then let's split the bottom up. Split the bottom half up into over 6. So that's going to be here, 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 here. We want 6 equal pieces, right? So that's here, here. That's 1 equal piece, 2 equal piece, 3 equal piece, 4 equal piece, 5 equal piece, 6 equal piece. So if this was 6 pi over 6 at pi, then add a pi over 6, that'd be 7 pi over 6. So this would be 8 pi over 6. Oh, wait, it already is simplified. Yes, it is. This would be 9 pi over 6. Does that simplify? Divide by 3, divide by 3. It sure does. Then this would be 10 pi over 6. Does that simplify? Yes, it sure does. And then last here to label, this would be 11 pi over 6. And then, of course, this would be 12 pi over 6, which would simplify to 2 pi. So isn't that cool the way you can go around the whole pi like that? So here's what I want to show you. When I do my quiz with y'all, that is exactly how I go around the circle. So of course I do the degrees with the pattern. I do 0. I know it's 0, of course, to start, and then I know it's add 30, add 15, add 15, add 30, add 30, add 15, add 15, add 30. I use that pattern to go around with my degrees. With my radians, I'm just letting you know, it takes me a while, but I do go around and I fill out the red first. So I think, oh, I already know these. This is 0. I already know this is pi over 2. I know this is pi. Actually, I really kind of go around like this. I go 0, pi, 2 pi. I know those quick. And then I know, oh yeah, this is half pi. So then I think to myself, and even though I don't write it, I think to myself, oh, I add a pi over 2. So I'm like 2 pi over 2. And I just make sure it simplifies. Yep, I'm good. And then I come down here, down here. And I'm like, okay, 3 pi over 2. And I fill it in real quick. And then I'm like, okay, if I go up another pi over 2, that's 4 pi over 2. And I check it and I'm like, oh yeah, 4 pi over 2, that simplifies. And I might not write these as I do it, but I do think about it mentally. And then, so of course, like I said, I start with the 0, the pi, the 2 pi. Then I go around with the pi over 2s. And then I go around with the pi over 4s. So then I'm like, okay, pi over 4. And then I'm like, okay, to get to the next, that's 2 pi over 4. And I might not write it, but I say it to myself and I think 2 pi over 4. Oh yeah, that simplifies. And then I go to the next red marking and I'm like, okay, so if that was 2 pi over 4, then add 1, that's 3 pi over 4. This is 4 pi over 4, 5 pi over 4, 6 pi over 4, check it in my head, 7 pi over 4, 8 pi over 4, check it in my head. And then I go to my over 3s and I'm like, okay, my 3, you just have to remember your ticks for pi over 3 are here, here, of course, here is your like mark point, your checkpoint for the whole pi, and then here and here. And you go, oh, pi over 3, 2 pi over 3, 3 pi over 3. In my head, check, I know that's 3 pi over 3, 4 pi over 3, 5 pi over 3, and then 6 pi over 3. Check and check, right? So then I go around with my pi over 6s and I'm like, okay, pi over 6, 2 pi over 6, yep. 3 pi over 6, yep. 4 pi over 6, yep. 5 pi over 6, and I need to write it because nothing's there. Okay, so hopefully that makes sense. And then I go 6 pi over 6. So I'm just kind of showing you how I go around. I've had other students say that they just memorize. I'm okay with that, I guess. Kind of, sort of, not really. I want you to understand where it all comes from. Now, if you can memorize it, and I guess it still makes sense and you can recall it fast, because what's going to happen is, I'm going to start to erase these because I don't want these on here anymore. But what's going to start to happen is when we get into later lessons, actually this lesson to be precise, here in the near future, I'm going to say real quick, where's 2 pi over 3? You know, and you're going to need to know really quick, oh yeah, 2 pi over 3, it's right here. You know, so you're going to have to recall where all these points on the unit circle are without having a unit circle in front of you, but actually just knowing where it is in your head. Okay, so hopefully you wrote in pencil on these, because you're going to need all this space to write your points. So now we need to go through and fill out your points. So these all come from your unit circle M-1 notes. So remember, this is the ordered pair 1, 0. This is 0, 1. I'm just starting the easy ones first. This is -1, 0. And this is 0, -1. Okay, and then you know, here's how I memorize this. Okay, I know that all my over 4s are square root of 2 over 2, comma, square root of 2 over 2. And this information, if you're wondering where I got this from, remember, this comes from your M-1 notes when I constructed the triangles. Okay, so this is square root of 2 over 2. All your over 4s are square root of 2 over 2. And I'm going to go back and show you how to do the signs. Okay, so all your over 4s are square root of 2 over 2. So square root of 2 over 2, comma, square root of 2 over 2 for all of the over 4s. So you're noticing all of the red marks in my case. Okay, and I know it's wrong right now. I'll come back and fix it. All my over 6s, all my purples, are going to be what I call bad news, good news. So when you go up and you hit that first angle, it's your pi over 6, okay? If we're talking radians. Okay, and me, I'm the type of person that I want bad news before I want the good news. So that's, we call this bad news, good news, because that's kind of like the uglier answer, because it's got the square root in the numerator. So this is your bad news, and this is your pretty answer, it's good news. So bad news, good news first. Okay, so all your over 6s are bad news, good news. They're all square root of 3 over 2, comma, 1/2. Okay, so I'm going around and I'm filling in all the purple markings, the over 6s. Square root of 3 over 2, comma, 1/2. And then right here, square root of 3 over 2, comma, 1/2. So all the ones that have the over 6 are your square root of 3 over 2, comma, 1/2. Now these, your over 3s, the green ones that we have here, the green ones in my case, these are our flip-flops. So flip-flop from this, that's what we call it, flip-flop. So 1/2, comma, square root of 3 over 2, 1/2, comma, square root of 3 over 2. And then 1/2, comma, square root of 3 over 2. Again, these are all your over 3s. And then 1/2, square root of 3 over 2. Once you fill that out, it's easy to just go back and based on the quadrant, fill in the signs. So here in the second quadrant, here in the first quadrant, let me start with that. You don't have to worry because x's and y's are positive, right? But here in the second quadrant, your x's are negative. So we're going to fill that out. Our y's are positive, so we leave that alone. Here in the third quadrant, both x's and y's are negative. So make sure that I can tell negative here. Don't let it get so close to the fraction bar or something, or the radical sign that I can't tell there's a negative on both there. And then here in the fourth quadrant, I've got positive x's but negative y's. So make sure you mark your y's negative. And that's it for that part, okay? So this is what you have to produce. This whole thing is what you have to produce in under 5 minutes. And I promise if you practice, you should print as many of the blank unit circles as you so wish, or I have plenty that I can give you, and you should practice going around filling this out a lot of times, getting your time under 5 minutes. Okay, so now let's talk about the actual lesson today. So I know, can you believe it? That wasn't even the lesson. Okay, so now what you're going to be asked to do on your assignment is something like this. You're going to be asked on your assignment today to find the ordered pair on the unit circle that corresponds to the given angle, which might be written as an angle, t or theta. Okay, so for example, if I want to know what ordered pair corresponds to the angle negative pi over 2 on the unit circle, you need to be able to think to yourself, okay, where is negative pi over 2? So you're going to draw, what do I want to use? I'll use blue. You're going to draw a makeshift circle. Okay, and you're going to think about where is negative pi over 2. Okay, so negative pi over 2 would be right here. You're going to put a dot there. Okay, negative pi over 2 is right here. What is the ordered pair right there on the unit circle? That's easy. It's just going to be 0, -1. So that's your answer. Okay, so when you have a pi over 2, one of the pi over 2s or one of the pi's or 2 pi or anything like that, this tends to be pretty easy. Okay, it's when you get to number 2, number 3, number 4, where you've got something over 4, something over 3, or something over 6 that is not quite as easy. But on the back of this, I've gotten kind of like a help sheet for you. So to help you, this is how I do it. Do you have to do it this way? No, but I'll show you what is required of you. So what I memorized, just like I talked about when I talked about filling in the ordered pairs here, is I know anything or something over 4 in the unit circle is going to take me to a square root of 2 over square root of 2. I just need to find out what is it over 4. Is it 3 pi over 4? Okay, is it 4 pi over 4, which would really be 5, but pi, so excuse me. Don't listen to me there. Is it like 3 pi over 4? Is it 5 pi over 4? Which quadrant am I in? Because you need to use the quadrant to determine the signs. Okay, so I'm just giving you the values, but you need to know if they're negative or positive in the x or the y based on the quadrant that you fall. So how I mark anytime I have over 4 is that's all I mark on my circle here, my makeshift circle. I draw my, the 0, the pi over 2, the pi, the 3 pi over 2, and then I draw my halfway in betweens, which are my pi over 4s, right? So that's all I draw when I'm given something over 4. When I'm given something over 6, this is what I draw. Okay, I draw my over 6s. So remember, that's a full pi. So your over 6s are when you take your full pi and you split it into 6 equal pieces. So that'd be 1, 2, 3, 4, 5, 6 equal pieces, right? And I know that if I have anything over 6, that's going to be your square root of 3 over 2, comma, a half. Now, I'm not saying all of these tick marks have a point, square root of 3 over 2, because some of these simplify down. Like this one, for example, is 2 pi over 6, which is really an over 3. So really this point here has this ordered pair. What I'm saying is, and it'll make sense more in a minute, but I would write this down, is if you have like 1 pi over 6, something that doesn't simplify, then you're going to land with something like this, but you need to use the quadrant to determine the signs. Okay, so that's what helps me for this. And then here's the deal. Here's what I do. Other teachers might not do this, but I do this. If I have something over 3, I don't like to see the full circle. Okay, and I'm going to show you this is the full circle here in a minute. You saw on each little quadrant, there's 3 markings within each. You saw that, right? there's 3 markings. You've got your pi over 6 marking, your pi over 4 marking, your pi over 3 marking, and then of course your 90 degrees or pi over 2. For me, when I'm given something, I don't like to draw the entire circle. It confuses me. I don't know what to count, okay? I want to know when I'm counting to get something over 3, I want to only know where my over 3s are, okay? So here I took my full pi and I split it up into 3 equal pieces. Do you see what I've done? I've split the top into 3 equal pieces and the bottom into 3 equal pieces. And then therefore I know that something over 3 is going to give me the flip-flop, okay? Something over 6 is the bad news, good news. Something over 3 is the flip-flop. And I forgot that I call this something over 4 twins, okay? Twins because they match. Alrighty, so if you want to draw the full circle when you draw your makeshift circle, I'm okay with that, but I'll kind of explain to you why I don't when we get to a more difficult problem here. And like here, I didn't draw the full circle because I didn't think it was really necessary. I just needed to know where negative pi over 2 was. Okay, so like for example, on number 2. On number 2, for me, I'm only going to draw my over 4s here because I'm dealing with over 4. So for me, I'm just going to draw this. Okay, so something over 4. Now, if you want to, all right, or if you're one of those people and you want to draw the full circle with all 3 marks here, here's my concern. You can do it. This is the full circle. But for me, I know where to count. Based on mine, I've only drawn my over 4s. So for me, this makes more sense. I'm going in the negative direction, so down and around, not up and around. I'm going in the negative direction, so I'm going to go down 1 pi over 4, 2 pi over 4, which makes sense because 2 pi over 4 would be pi over half, right? And then 3 pi over 4. So I know I just tick 1 tick, 2 ticks, 3 ticks. This point right here would be negative 3 pi over 4. So I already knew from over here that anything over 4 was my twins. I knew it was going to be twins. I knew it was going to be square root of 2 over 2, comma, square root of 2 over 2. I knew it was going to be those numbers, okay, based on the over 4. But I needed to know the quadrant to know which of these, if any, was negative. So now, since I'm in the 3rd quadrant, I know both my x and my y are going to be negative, so that's my ordered pair. Now, you could do the same thing where you draw the full circle, but for me, it's very confusing to see where do I count. But maybe for you, it's okay. So you would have to know that you skip that and you go, this is 1 pi over 4, this is 2 pi over 4, and you'd have to know that this was 3 pi over 4 right in between here. So if you want to draw the full circle, that's fine. Like I said, for me, it kind of confuses me, but I would accept either way. Okay, either way, you should end up with the same answer as long as you're doing it correctly. Okay, so on number 3, let's talk. We've got an over 3, so anything over 3, remember over 6 is our bad news, good news. Over 3 is our flip-flop. So over 3 is going to be for sure this, remember, for sure that. But now I need to know my quadrant. And like I said, for me, I only draw my over 3s. So I only draw these. But if you're the type of person that wants to draw the entire circle with all 3 marks, that's fine as long as you know what to count. So for me, it's easy to see that it's positive, so I'm going to go up and around, not down and around. It's positive, so I'm going to go 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. I make that full revolution. So that's 6 pi over 3, 7 pi over 3, 8 pi over 3 is going to put me here. So you could do it using the full circle, but you just need to make sure you remember you're only counting these. You don't count that. That's why it's so tricky for me to do it with this. I like get lost in what am I counting and what am I not counting. So you might want to mark them darker, kind of like I did if you do it this way. So you would go up and around 1, 2, 3, 4, 5, 6, 7, 8. So like I said, it's still going to land you in the same spot. You just have to be careful about what ticks to count and which ones not to. So here we've got the 2nd quadrant is where we are. So that's going to be a negative x, but a positive y. So that's your answer. Okay. All right, last but not least, 13 pi over 6. So again, for me, I do better when I mark my over 6s. So that's just going to be these. I don't count the ones in the middle. Because hold on, let me just double check myself. So that's 1, 2, 3, 4, 5, 6 equal pieces. So I should have 6 equal pieces before I get to the whole pie. Or again, if you want to use the full circle, then you know that boom, 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 boom. Okay, you know you're only talking about this guy, this guy, this guy, this guy, this guy. You skip those, the 45 markings, but not anything else. Okay, so as long as you know that. So then I'm going to go around, 13 times. But y'all, you should know a full revolution is 12 pi over 6. So 13 pi over 6 would put me right back here. So same, a full revolution would be 12. And then just up one more would be 13 pi over 6. So that's going to put us in the first quadrant. And remember, I should have done this before, but anything over 6 is bad news, good news. Square root of 3 over 2, comma, a half. And since we're in the first quadrant, we don't need to mark any negatives. That's our final answer. So that's the lesson from in class today. So you have your IP M-1. Go ahead and get started.